Hello, my name is Bruno, and it's me again talking about chemical stuff. So today I'm going to talk about chemical bondings. In this case, I'm talking about ionic bonding, covalent bonding, and metallic bond. First of all, what's an ionic bond? You're probably asking at this moment about talking about bonds. What is a bond? A bond is like a fusion or union between two elements. This fusion, what is going to happen is that one is going to give one or more electrons to the other. Why is happening this? Because they need to become stable, and for this they are going to need 8 electrons in the outer shell. But why? Well, in the nature it's not to be like too easy to find an element that is going to be stable at all. They're going to be probably unstable, exception for the noble gases. The noble gases are located in this part of the periodic table. I probably wonder why they're called noble gases. It's because, as the name says, they are going to be noble. Like, oh, I don't want to fusion to the bond with copper because copper smells really bad. I don't like it. No! And that's going to happen actually with the noble gases. They are not going to fusion it with other element. So because they are actually stable, they have the 8 electrons in the outer shell. And that's why they need to fusion with other, because all the elements want to be stable. Want to have a relation with other elements, you know, the happiness, the love. Well, and we're all exploring the noble gases, and all the other elements can fusion and bond with others. So now, moving back to the topic about ionic bond. In this case, what is going to happen is that this bond is only going to happen with metals, with non-metals. What's happening is because they are going to be like attract between these elements, and yes, they're going to be out positive and negative charges, and it's going to be pretty similar. Well, are going to be the same rules as the magnets. If you remember, the rules is that different charges are going to be attracted and equal charges are not. So now with all of this, we need to be a very interesting thing is that this bond is only going to happen from the metal to the non-metal. What I mean, the metal is the only one who is going to give an electron to a non-metal to become stable. It's not going to be vice versa, that the non-metal is going to be electrons to the metal. No! Why? Because in the periodic table, the non-metals only need 1 electron to become stable. So it means that they have 7 electrons in their outer shell. So with only giving obtaining one, they're going to achieve these 8 electrons. With the metals they're only going to have 1 electron, so they are going to be 7 to be complete. So the metal, what they do, you say, no, 7 electrons is too much. Yeah, better I give 1 and the others give me a reward. Yeah, I'm going to give my electrons to a non-metal. I want to be stable. And what's going to happen? The metal is going to be an electron to the non-metal to become stable, because it's going to be more easy. And in these cases, we are going to use a phrase that they are going to win or lose an electron, because well, the metal is only going to lose an electron and the non-metal is going to win one. But it also can happen with more electrons if they are being attracted, like with positive and negative charges. I'm talking back about the phrase they win or lose an electron. Also, what is going to happen is that one element is going to become more positive and the other more negative. Why? We need to use these like little rules that if an element has less electrons, it's more positive, but if an element has more electrons, it's more negative. Why? Because remember that electrons are going to be negative, they're going to be bad guys. So what will happen here is that the electrons that are going to be negative, and between more negative things you have, they're going to become more negative, and if you lose, they're going to be positive. So in these cases, the metal, they're going to become more positive because they're going to lose an electron, and the non-metal is going to become more negative because they are winning an electron. So that time of technology. For this time of technology, I like to use the money. just think about two friends that are going to buy something and they don't have enough money. Maybe one of them are going to be some chips and it costs 15 pesos. One of them have 10 pesos and the other 5. So what they're going to do is one is going to give the pesos to the other and they're going to buy the chips. And for this I'm going to use the example. Pablo, hey, I want to buy a hamburger. Pablo, hey, I want to buy a hamburger. It costs 25 pesos. I have 20. You want to buy it? You give me 5 pesos. I can obtain the hamburger. Boo! Thanks. The next bond is going to be the covalent bond. The covalent bond is going to happen with non-metal. It's going to be non-metal and non-metal. So in this case, to locate the non-metals are going to be in this part of the periodic table. And now with that, the mission of this covalent bond is to the boat. In this case, going to be the boat. In order to be like one, like the titanium bond, that is only one is going to be if the pesos, the electrons to the other to be complete. In this case, both are going to try to obtain the 8 electrons. So for this, they are going to share these electrons. It's not like the ionic that is going to win or lose an electron. In this case, they are going to share. So for this, we're going to put these examples about the oxygens. In the outer shell, they have 6 electrons. So to have 8, they are going to need 2 more. So for this, what we're going to do is that one oxygen is going to pass 2 electrons and the other is also going to pass 2 electrons. So they're going to be like this, like balance or some similar. But they're going to happen is they're going to share these 2 electrons. For this type of analogy, I like to use the food. Because in this case, as too many say, we need to share our food. This is going to happen as to say. Maybe you think about you have a sandwich and maybe one friend has some chips. And the both of you want to taste the food of each other. So you're going to share the food with him and also your friend is going to share his food with you. So now with analogy and example. Hey, I have a tostachos and a Pepsi. You want to share our food? Oh yeah, boy! I have my egg sandwich. Let's share our food and eat from them. And finally, we have the last one. Today I'm talking about the metallic bond. The metallic bond is going to be really interesting. In this case, it's going to happen with the metals and metals. The objective in this case, and different from the others, is to become more positive. Even if the metals are positive without having this metallic bond, they want to become more positive. They're going to be very good people, very positive, with a good life for the future. So for this, what they're going to do is to create or form the electron clouds. What's an electron cloud? For this, I put this example about iron. So in this case, what is going to happen is that when they're going to bond, are going to liberate electrons. In this case, I want to become more positive with that. The name of electron cloud is given because of their shape. That is like a cloud. What's going to happen here is the elements, as I already said, they're going to like liberate all these electrons to become more positive. And for this analogy, I like to say about shops and people. Just thinking about maybe you're walking on the tianguis, you probably know there are a lot of shops many places when too many people are designing things. So too many people are walking around them, trying to buy something, and in this case, the shops are being positive because they are winning money from that, and the people are wasting money, so they are becoming like less positive, less money. So that's all for today. For watching. How is this gonna help me in my engineer life? Yes.